Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables, Video 11, Evaluating the Truth Value of a Compound Statement for a Specific Case. In the previous video, I kind of implied there would be two more videos, another truth table for a compound statement made with three simple statements, and then a follow-up. I've decided to go straight to the follow-up. I think the two previous examples were clear enough, since the only difference between the two previous examples and the ones that preceded it were the number of rows, not necessarily how to construct each column and how to populate each column. But don't worry, there will be more truth tables in subsequent sections, so you'll see plenty of them. But I wanted to show you an example of evaluating the truth value of a compound statement without necessarily making a truth table. A truth table determines the truth value of a compound statement under all possible scenarios, whether all of its simple statements are true or all of them are false, or there's some mixture of true and false statements among the simple statements. But sometimes we're not concerned with every possible combination of truth values. We're only looking at a specific case. Let's take this particular example. Not that any politician would ever say or do any of these things. A politician makes the following statement, which we will call statement A for convenience. A, I did not take a bribe, and if I did take a bribe, I would not run for office. Suppose the politician did take a bribe and did not run for office. When he said statement A, was he telling the truth? All right, so think of this as something that's happened in the past, something he said in the past, and then something occurred in the future. What he said in the past was, I did not take a bribe, and if I did take a bribe, I would not run for office. Let's just say he said this on June 1st, 2020. And then in the future, this, let's say this occurred on July 1st, 2020. It was discovered he took a bribe and he ended up not running for office in the future. Is the statement he said on June 1st true or false? Was he telling the truth? You know, a lot of people cannot answer that question based on the structure of statement A, which if you'll notice, statement A contains a conjunction, there's an and, but there's also a conditional, an if then, even though the word then is not stated. If I did take a bribe, then I would not run for office. But with symbolic logic, we can analyze whether or not statement A was true or false when he said it. How? Well, the first thing we need to do is translate everything from symbols to words. And we need to identify our simple statements. So let's start by, not sure what happened there. Actually, I know exactly what happened there. Let's start by first identifying the simple statements. There are two key simple statements in here, and if we take them without the word not in them, one of the statements, which we'll call P, is the politician took a bribe. Let's stretch this, there we go. And we'll let Q be the politician ran for office. Now you might be arguing, but in these statements, the subject was the word I, and these statements were in first person. We changed the subject to politician and changed it to third person. But I've said before that when you are translating words to symbols, you do have some flexibility with tense, and in this case, person in the statements. As long as they convey the same idea, it's okay. Now, if we let the politician, P be the politician took a bribe and Q be the politician ran for office, how would we translate statement A symbolically? Give me a second to copy it, and then we'll move it down here. Let's remove the quotes. All right. So would you say that this is primarily a conjunction or primarily a conditional? The hint is where the location of the comma. After the comma is the word and, that is a conjunction. And now we look on both sides of it. On the left side is I did not take a bribe. Well, if P is he took a bribe, what is he didn't take a bribe? That's the negation of P. And now look to the right of the conjunction. And remember, the word then is implied here. If I did take a bribe, then I would not run for office. Because this is another compound statement after a connective, it is going to go in parentheses. If I did take a bribe, so if P happened, then I would not run for office, negation Q. By translating the statement A into symbols, we can evaluate its truth value, but not necessarily by constructing a truth table. Why not construct a truth table? Because we don't need to. A truth table determines the truth values of this compound statement for every possible combination of true and false for P and Q, but we have specific values for those. The politician did take a bribe. Now, what does that mean? We know that P is true. He did take a bribe. He did not run for office. What was statement Q? I meant to put a blue box around there and say that's P. He did take a bribe, so P was true. But he did not run for office, and Q was the statement he ran for office. So is the statement Q true or false? Well, if Q is he ran for office, but he didn't, then Q is false. So here's what we know. He said this, P is true, and Q is false. So what can we do with that? Well, let's take a look at the next page and see. We are trying to answer this question. If P is Q and true is false, what is the truth value for negation P conjunction P pointing to negation Q? Or equivalently, what is the truth value for not P and if P, then not Q? Let's make sure we wrote that correctly. We did. Now, we could build an entire truth table and look in the correct row, the row where P is true and Q is false. I believe it would be the second row. But if you're really only interested in one row in a truth table, don't build the entire truth table. Instead, here's what you can do. We're going to substitute, if I can get this to type, we're going to substitute T for P and F for Q in the compound statement and evaluate its truth value based on the hierarchy of connectives and the basic rules. Now, at this point forward, whenever I say the basic rules, I mean the rules for negation, conjunction, disjunction, conditional, and biconditional. I'm not going to write them all, but I'll remind you what they are. The rule for negation is change the truth value. The rule for conjunction is true only when all of it is true. The rule for disjunction is false only when all of it is false. The rule for a conditional is it's false only when you break your promise, only when T points to F. And the rule for biconditional is it's true only when both halves have the same truth values. Let's see what happens if we take this compound statement and replace each simple statement with its known truth value. We know that the statement P, which is I took a bribe, was true. So we'll put a T there and a T there. We know the statement I will not run for, the statement I will run for office, that's what Q was false. So we'll put an F there. Now, how do we evaluate this? Well, it's almost like an arithmetic problem. For example, if you had something like -5 plus 3 times -2, there is a correct order in which to do that. You would multiply and then you would add. But if we're doing something like this, there's a correct order in which to do it using the hierarchy of logical connectives. Just like when building a truth table, let's figure out what to do first. There are parentheses, we go inside of there first. In the parentheses, there is a conditional and a negation. Which of those takes precedence? The negation. So we are going to do the negation first. Who is the negation on? The F. And what does negation do? Negation changes the truth value. So our first move is to change this truth value. This is value, not valve. By the way, value and valve are the only pair of words that I know of where you can change a U to a V and get a new word. All right, so what would that look like if we did that? If we played out that first move, we would still be left with negation true and true pointing to, now the negation of false is true, and now we have that. So at this point, where are we in the hierarchy? Well, we still have a parenthesis, so we go inside of there, and the only connective in there is a conditional. And what is the rule for conditional? The rule for conditional is it's false only when T points to F. Do we have T pointing to F? We do not. That means that when we evaluate this, according to the rule, that will be true. So now we're at negation T, and the parentheses evaluates to true. Okay? T pointing to T is true. The only time you have false is T pointing to F. At this point, we're down to a single connective. The connective we're left with is a conjunction. And what is the rule for conjunction? Excuse me. That is not what we do next. We have two symbols left. We have a conjunction and a negation. And which one happens first? The negation. So next we evaluate the negation, and then the rule for the negation is the same as it was before. Change the truth value. I'm just going to write it from this point on. If we apply the negation to the true, changes the true to false. Now we have false and true. And what is the rule for conjunction? The rule for conjunction is it's true only if all T's. Does this satisfy this rule? It does not, which means that is not true, which means it is false. And what that means, therefore, I haven't used this 3-dot triangle in a while. Therefore, actually, let's go back to the previous page so I can copy the question. And we will just drop a text box here. Maybe paste the question. When he said statement A, was he telling the truth? I did not tell you to leave the text box. When he said statement A, was he telling the truth? The answer is no, he was telling a lie. Which may not have been immediately obvious just by all the evidence that you had in front of you. Namely, that he had said statement A. That 3-dot triangle is bothering me now, but I'm not going to mess with it. When he said statement A prior to him being caught for taking a bribe and then not running for office, then he actually told a lie. Now, did he do the wrong thing? No, he caught a bribe. He shouldn't have run for office. So I think we can agree he did the wrong thing. But what this means is when he said this first statement, the one right here, and then this happened, that made his first statement false. And actually, it was false right out the gate. We didn't even have to worry about the conditional. The minute he took a bribe, the statement was false. Why? Because the minute he took a bribe, this statement was false, and it was the left half of a conjunction. And what's the rule for conjunction? It's true only when it's all true. So the minute he took that bribe, the first part of the conjunction was false, making the whole conjunction false. So there was no chance for it to be true at all. So he shouldn't have took the bribe. Now, had he said, I did not take a bribe, or if I did take a bribe, then I would not run for office, that would have been true, because if he said or, then down at this point, we would have had false or true, and that is actually ends up being true. So did he mean to lie? No. Did he mean to take the bribe? Probably. Did he mean to get caught? Of course not. But the point I'm making is people are really bad about determining if long statements are true or false. Because the more ands, the more ors, the more if-thens, the more if and only ifs you throw in there, the tougher it becomes to determine if a statement is actually true or false based on what those words mean and based on those rules for symbolic logic. So even at this point, we do have a tool for analyzing if somebody's really long, convoluted statement is true or false. Next time you're watching a politician or a press reporter or the White House press reporter, I forget her name, say a statement, listen closely or read the transcript. See how long the sentences are. They tend to be really long, and as a consequence, they tend to contain a lot of connectives. And as a consequence of that, it blurs whether or not the statement is true or false, regardless of whether or not the simple statements are true or false. So it takes a lot of practice to be able to analyze the truth value of long statements. Actually, it doesn't take that much practice at all. You just need to know a few things: hierarchy of connectives, how to represent things symbolically, and your rules for negation, conjunction, disjunction, conditional, and biconditional.